Welcome to my presentation. In this presentation, we shall see the different laws related to exponents. There are several laws related to exponents. We will list them out, we will talk about those, and then we will use them to solve some simple examples. So let's get started. If m and n are positive integers, let me write this, and if x and y are real numbers, then the rules can be stated as follows. The first one, we'll call it as the product of two powers. Product of two powers. And in here, what are we trying to say? If we have an exponent of this nature, x to the power of m, and if we have another exponent, x to the power of n, as long as the bases are the same, we can write the base once and then we can combine the powers, m plus n, like that. That is called the product of two powers. The second rule is power of a power rule. Power of a power rule. And then here we're going to say, if we have an exponent x to the power of m of that nature, and if this exponent is raised to another exponent to the power of n, the way we're going to write this one out is as follows. We write the base and we multiply the exponents, m times n, m multiplied by n. So that is the power of a power rule. Then the third one is power of a product. Power of a product. Power of a product. And how do we write this? If we have two terms, x and y, and if both these terms are raised to a power m, every one of the terms inside the parentheses will be raised to that power, like this, x to the power of m times y to the power of m. Okay, so let's state some more rules in here. The fourth rule is power of a quotient. Power of a quotient. Power of a quotient. A quotient is like a ratio. We can think about it as a ratio. X over y. If we have terms x over y like that, and then these terms are raised to the power of m, every one of the terms will be raised to that power. X to the power of m divided by y to the power of m. So that is called the power of a quotient. And then the fifth rule is quotient of two powers. If we have, let me write this, quotient of two powers. Quotient of two powers. In here, if we have x to the power of m in the numerator, and if we have x to the power of n in the denominator, we can write this as x to the power of m times x to the power of negative n. When we have an exponent in the denominator with a positive exponent in the denominator, we can bring it up to the numerator, and when we bring it up to the numerator, the exponent from a positive changes to a negative, like the way we've shown here. X to the power of positive n, which is in the denominator, when we bring it up to the numerator, it becomes x to the power of negative n. And therefore, we can use the first rule which is the product of two powers, and since the bases are the same, we can write the base once and then we can combine the powers like m minus n, like that. So that is the quotient of two powers. So there are some more special rules in here, and we're going to state that as well. If x is a non-zero real number, if x is, let me state this here, if x is not equal to 0, then x to the power of 0 is equal to 1. Okay? Then we can also write one more. If n is a positive integer and x is a non-zero real number, let me state this. If n is a positive integer, and x is not equal to 0, and x is not equal to 0, then we can state that x to the power of negative n, we can write that as 1 over x to the power of positive n. That means if we are given an exponent which has a negative power, we can write that as 1 over a positive power, like this. Or if we have a positive power, x to the power of n, in the numerator, we can write that as follows: 1 over x to the power of negative n. If we have a exponent which has a positive power in the numerator, we can rewrite that by bringing it into the denominator and then converting the positive exponent to a negative exponent, like what we have shown here. These are the laws of exponents. We will use these laws to solve some simple examples. In my next presentation, we shall look at examples as to how to solve problems using these laws of exponents.